Welcome everyone in lecture number 15. Today I'll discuss a new method of finding inverse Laplace transform. This method is called Heaviside expansion theorem. तो सबसे पहले मैं आपको ये बता दूं कि इस मेथड का यूज आपको कब करना है। इस मेथड के लिए आपको जो क्वेश्चन गिवन होगा वो एक फंक्शन होगा, ऑब्वियसली फंक्शन ऑफ पी, और वो फंक्शन इस तरह का फंक्शन होगा कि आप उसको दो पार्ट्स में डिवाइड कर सकते हो. One part is the numerator part and another part is the denominator part. न्यूमरेटर में जो फंक्शन है दैट इज अ पॉलिनोमियल एंड डिनोमिनेटर में जो फंक्शन है वो भी एक पॉलिनोमियल है. लेकिन ये दोनों पॉलिनोमियल कुछ कंडीशंस को अगर सेटिस्फाई करते हैं तभी हम इस मेथड का यूज कर पाएंगे. वो कंडीशन क्या है? व्हाट इज द कंडीशन that fp and gp has to be satisfied? The condition is that degree of fp should be less than degree of gp because these two are polynomials. क्योंकि दोनों polynomial है तो कोई ना कोई डिग्री तो होगी इनकी. तो न्यूमरेटर में जो पॉलिनोमियल है उसकी डिग्री छोटी होनी चाहिए डिनोमिनेटर के पॉलिनोमियल की डिग्री से. ओके. सेकंड कंडीशन क्या है? सेकंड कंडीशन ये है कि आपको जीपी को फैक्टराइज करना है. फैक्टराइज ऐसे करना है कि सारे फैक्टर्स लीनियर हों. इस तरह से लीनियर फैक्टर्स हैं ये सारे, और जो अल्फा 1 अल्फा 2 अल्फा n है दीज आर रियल और कॉम्प्लेक्स, रियल और कॉम्प्लेक्स कांस्टेंट्स एंड ऑल आर डिस्टिंक्ट. डिस्टिंक्ट मीन्स कोई भी जो कांस्टेंट है वो सेम नहीं होने चाहिए. नो टू कांस्टेंट शुड बी सेम. ऑल द रूट्स शुड बी डिफरेंट. अगर आपके फैक्टर्स सपोज ऐसे आ रहे हैं जीपी के p-1 p-1 p-2, तो यहाँ पे दो कांस्टेंट रिपीट हो रहे हैं. दे आर सेम, अल्फा 1 एंड अल्फा 2 आर सेम. तो इस केस में ये थ्योरम नहीं अप्लाई हो सकती. ये थ्योरम तभी अप्लाई हो सकती है जब सारे अल्फा आईज डिफरेंट हो एक दूसरे से, चाहे वो रियल हो या कॉम्प्लेक्स हो. ओके. So if these two conditions are satisfied for the given function, then Laplace inverse of mm, Laplace inverse of fp upon gp type of function will be summation f of alpha r g dash of alpha r e raised power alpha r t. Means we have to find the value of function fp at each alpha i's and value of the derivative of this polynomial at those alpha i's multiplied by e raised power alpha r t. If suppose there are three factors, then r will be from 1 to 3, and we write this as, if we expand this, then we write this as g dash alpha 1 into e raised power alpha 1 t. This is for first root. Similarly, you have to do it for second root. And so on up to nth root. Okay. So in this way, this expression, when you simplify this expression, if it is possible to simplify, then this will gives Laplace inverse of this function. So let us take one example. Find Laplace inverse of p square minus 6 whole divided by p cube plus 4p square plus 3p. Now you can use method of partial fraction also here, and we check that if we can use a method of Heaviside expansion theorem or not. For that हम न्यूमरेटर में जो फंक्शन है उसको fp से डिनोट कर देते हैं और डिनोमिनेटर में जो पॉलिनोमियल है that is denoted by gp and its value is p cube plus 4p square plus 3p. Now we check condition number 1. Degree of fp, which is equal to 2, and degree of gp is equal to 3, and since 2 is less than 3, first condition is satisfied. First condition of, मैं शॉर्ट में लिख रही हूँ, हेवीसाइड एक्सपेंशन थ्योरम इज, वैसे ऐसी कोई शॉर्ट फॉर्म होती नहीं है. To save the time I am using this. H for Heaviside, E for expansion, T for theorem. So first condition of this theorem is satisfied. Now second condition is, to check the second condition we have to factorize GP. So GP is P cube plus 4P square plus 3P. क्योंकि ये क्यूबिक पॉलिनोमियल है तो इसके रूट्स निकालने के लिए आपको 2 स्टेप्स फॉलो करने पड़ेंगे, जिसमें फर्स्ट स्टेप में यूज हिट एंड ट्रायल मेथड, और हिट एंड ट्रायल मेथड से आपको पहला रूट मिल जाएगा. उसके बाद आपको एक फैक्टर मिल जाएगा, उस फैक्टर से आपको इस पूरे पॉलिनोमियल को डिवाइड करना है, तो उससे आपको दूसरा फैक्टर मिलेगा. And then we do the factors of second quadratic polynomial that we obtain when we divide this polynomial by one of the factor. Okay, इस तरह से आपको तीनों फैक्टर्स मिल जाएंगे. तो मैं आपको शो कर देती हूँ ये मेथड आपको कैसे फॉलो करना है. जब आप इसमें p इज इक्वल टू 0 सब्सटीट्यूट करेंगे तो 0, ये पूरा पॉलिनोमियल 0 की इक्वल हो जाएगा. तो we can write that p is one of the factor of gp. So to obtain the other factors, what we do is we divide p cube plus 4p square plus 3p by p. So divide करेंगे, we'll take here p square and then 4p square, 4p square. Then we have 3p. 3p हम जब कॉपी करेंगे, so we'll add 3 here. So 3p will be here also and they will cancel. So we have this factor. This implies GP can be written as uh, p into p square plus 4p plus 3. तो सेकेंड फैक्टर मिल गया. ओके, सो जब आप इसके फैक्टर्स करोगे, 3p plus p plus 3p plus 3 into p plus 1. Okay, this implies alpha 1 की value 0, alpha 2 is -3 and alpha 3 is -1. All the alpha i's are distinct. Second condition of Heaviside expansion theorem is also satisfied. Okay, now we are ready to apply this theorem on this function. This implies Laplace inverse of p square minus 6 p cube plus 4p square plus 3p will be equal to summation r is equal to 1 to 3 because there are 3 roots, f of alpha r divided by g dash of alpha r into e raised power alpha r t. Now this implies Laplace inverse of p square minus 6 divided by p cube plus 4p square plus 3p is equal to f of alpha 1 g dash of alpha 1 e raised power alpha 1 t, f of alpha 2 g dash of alpha 2 e raised power alpha 2 t, f of alpha 3 g dash of alpha 3 e raised power alpha 3 t. अब अल्फा 1 अल्फा 2 अल्फा 3 की वैल्यू सब्स्टिट्यूट कर देंगे. f of -3 and -1. f of -1 g dash of -1 e raised power -t. अब f 0 पर, f की वैल्यू 0 पर, ये एफ टी है. यहाँ पर हम g डैश p की वैल्यू फाइंड आउट कर लेते हैं. 2p plus 8p plus 3. Okay, f of 0 is -6. We substitute 0 here, we'll get -6, and when substitute 0 here, we'll get 3. Okay, this is 1 plus -3 square -6 and 2 into -3 plus 8 into -3 plus 3 e raised power -3t plus -1 square -6, 2 into -1 plus 8 into -1 plus 3. Put this in the bracket, e raised power -t -2 this is 9 minus 6 3, and this is minus 6 minus 24 plus 3. I think I have done the wrong calculation here. Derivative of g here is 3p square. Yes. So here I should correct this. Mm, 3 into minus 3 square plus 8 into minus 3 plus 3. And here we have 3 into minus 1 square plus 8 into minus 1 plus 3. So in numerator we have 3, 27 minus 24, 3 plus 3, 6. And that is minus 5 divided by 3 plus 3, 6 minus 8. 6 minus 8 is minus 2. So it is 5 upon 2 e raised per minus t. So you can write minus 2 plus 1 upon 2 e raised per minus 3t plus 5 upon 2 e raised per minus t. This is the answer. Okay. Next example is find the Laplace inverse of p cube plus 16p minus 24 p4 plus 20p square plus 64. So first condition is satisfied here. Numerator degree is less than denominator degree. To check the second condition, we have to factorize this. We denote this by fp, this by gp. इसके फैक्टर्स आप फैक्टर्स करेंगे तो फैक्टर्स तो नहीं हो पाएंगे. हिट एंड ट्रायल मेथड से आपको पहला रूट कभी नहीं मिल पाएगा इसमें. तो इसमें हम क्या कर सकते हैं, हम इसको ऐसे लिख सकते हैं. We can write 16p square plus 4p square plus 64. Take p square common. P square plus 16 plus 4p square plus 16. P square plus 16 p square plus 4. P plus 4i p minus 4i. इसको लिख सकते हैं ऐसे. And this can be written as p plus 2i p minus 2i. So this is alpha 1. Sorry, alpha 1 is minus 4i. Alpha 2 is plus 4i. Alpha 3 is minus 2i. Alpha 4 is plus 2i. Okay. So these are 4 roots of this polynomial, which are all distinct, but they are all complex. Now we find the derivative of this function is 4p cube plus 40p. Okay, this implies Laplace inverse of fp over gp is equal to f of alpha 1 divided by g dash of alpha 1 e raised to the power alpha 1 t plus f of alpha 2 g dash of alpha 2 e raised power alpha 2t f of alpha 3 plus g dash of alpha 3 e raised power alpha 3t f of alpha 4 g dash of alpha 4 e raised power alpha 4t. Okay, now is equal to, you can put the value of alpha 1 here. So this is minus 4i cube plus 6 into 16 into minus 4i minus 24 divided by 4 into minus 4i whole cube plus 40 into minus 4i. The calculation is quite lengthy here. This I have done for this part. You have to repeat this for each and every term here which is written here. Second is f of alpha 2. So I write here 4i whole cube plus 16 into 4i minus 24. 4 into 4i whole cube plus 40 into 4i and so on. I am not doing this for these two. You do it by yourself. So by simplifying all these terms, at last you will get, I tell you the answer, and the answer is 1 upon 2 sine of 4t plus cos of 2t minus sine of 2t. Okay, so try it yourself. I move on example number 3. Find Laplace inverse of 2p square plus 5p minus 4 divided by p cube plus p square minus 2p. Again, first condition, if they denote by fp, this is gp, degree of fp is less than degree of gp. First condition is satisfied. To check the second condition, we have to do the factors. So by hit and trial method, first factor will be 0. So you can divide this whole by p, we'll get the other factors. So factors of gp are p into p plus 2 into p minus 1. So that alpha 1 is 0, alpha 2 is minus 2, and alpha 3 is 1. Okay, so you can Also do it by yourself, substituting all the values. Laplace inverse of fp upon gp will be equal to summation f of alpha r, g dash of alpha r is equal to 1 to 3 e raised power alpha r t. So when you solve it, you will get 2 minus e raised power minus 2t plus e raised power t. Okay. Next example is find Laplace inverse of 3p plus 1 whole divided by p minus 1 into p square plus 1. Here gp is already factored and the roots are 1, and this can be factored as p plus I and p minus I. So roots are the mixtures of real and imaginary numbers. So alpha 1 will be 1 and alpha 2 here is I and alpha 3 is minus I. So there are 3 roots, all are distinct, and the degree of numerator is 1, which is less than the degree of denominator, which is 3. So all the conditions are satisfied. Okay, you can apply this theorem here in this question. Okay, so try it yourself. I'll tell you the answer of this question in my next video lecture. Okay, I hope you understand today's lecture. And if you like my lecture, please press the like button, subscribe my channel if you had not subscribed it yet, to get the notification of any new video on the Laplace transform. Thank you so much.